Our next presenter is Ishna Satyarth in the Computer Science PhD program. Ishna's presentation is titled Application of Machine Learning in Reduced Scaling Quantum Chemistry.
So, if you can fathom quantum chemistry without getting dizzy, you don't get it. These were the words by Dr. Neil Bohr, a pioneer in quantum chemistry. Now let me try my own ignorant audacity to prove Dr. Bohr incorrect. So, how many of you have shifted your sitting position since you have come here? We move from one comfortable position to another. Something similar happens with the molecule. The arrangement of atom in the molecule is such that it leads to one or more equilibrium configuration or stable state. So the energy in here is minimized and the molecule is stable. So when the molecule moves from one equilibrium state to another, it passes through a transition which has certainly a higher energy shown in the blue curve. Now to compute this curve, we are using third order molecular perturbation theory or MP3. The MP3 energy can be determined by looking at the relationship between the wave function psi, which represents the probability of finding an electron at different locations, and the Hamiltonian H, which represents the interaction between the electrons. Now this can be represented diagrammatically in the right, and each of these 10 diagrams result in a numerical contribution to energy, which can be computed, and they have a distinct error associated with it. Now although MP3 is fairly accurate, but it takes a lot amount of time to compute. So which is a trade-off between speed and accuracy in any of the quantum chemistry calculations. So to reduce this computational cost, we are applying an approximation technique called THC, which fairly increases the speed of the calculations, but it reduces the accuracy of the result. Now, this is where a computer science engineer like me entered the world of quantum chemistry. Now, I am applying an artificial neural network in THC and MP3 to decrease this error by feeding a network with input variables, 34 in our case, and feeding them in the forward direction, and then back propagating the error by adjusting the weight which are associated with these energy values. Now we have thus far trained our model on more than 2700 molecules, different molecules, and we have also obtained this combination of hyperparameters out of more than 11,000 combinations. So by using our AN model in THC and MP3, we are trying to bridge this gap of speed and accuracy, and we are trying to achieve a higher quality result in a less time. I hope I didn't make you all lazy.